In this video, we will solve a problem on volumetric strain. So first we will read the problem and we'll go step by step here. Okay, a 300 millimeter long bar with rectangular cross section. The 80 millimeter into 20 millimeter. It is a first we'll draw the bar here. A 300 millimeter long bar. Its length is 300 millimeter. $300 long bar with rectangular cross section 80 mm by 20 mm. Its cross section is rectangle. Rectangular cross section 80 mm by 20 mm. 80 mm is its width and 20 mm is its thickness. That is 20 mm is its thickness. This is thickness 20 mm, T equal to, and this is L, length, and width is 80 mm. 80 mm is subjected to an axial tensile force of 300 kilonewton along its length. It is subjected to axial tensile load along its length. This is length, so this is subjected to an axial tensile load of plus 300 kilonewton along its length. Okay, just I'll draw this one. This axis is, this is X and this is Y and this one is Z. This one is Z direction. Okay. Taking E equal to 200 GPa. Young's modulus, he is given. What is the data? The data E equal to 200 GPa. That is gigapascal. E equal to 200 GPa. Convert this into MPa, megapascal, or Newton per mm square. Both are same. That is 200 into 10 raised to 3 MPa. That will be equal to 2 into 10 raised to 5 MPa, megapascal, or Newton per mm square. E equal to 200 GPa and nu, Poisson's ratio equal to 0.3. Nu equal to 0.3. Determine first bit, strain and deformation along all its sides. You need to find out the strain in x-axis, strain in y-axis, and strain in z direction, and deformation, that is change in length. In how much change in length in x direction, change in length in y direction, and change in length in z direction. That is the first bit. That is what we need to find out. Strain all the direction, all the sides. I will write strain in x direction is how much, strain in y direction is how much, strain in z direction is how much. Also deformation, that is deformation in all sides. That is deformation means change in length. In x direction is how much, change in length in y direction is how much, and change in length in z direction is how much. That is first bit. And second bit is change in volume. Total change in volume how much? That is change in volume equal to how much? That we need to find out here. Okay. Okay, now we'll go one by one here. First bit, to find out the first bit, strain in x direction, strain in y direction, strain in z direction. Okay. First I'll go strain in x direction. Strain in x direction, we have the formula, that is strain equal to stress by E, normal formula. That is stress in x direction, stress by E. Stress along x direction, stress along x direction divided by E. Okay. So next, strain in y direction. How we will find out? Strain in y direction is minus nu into stress in x direction divided by E, because it is along the lateral side y direction. Related to the x, it is minus nu, where nu is Poisson's ratio. Similarly, strain in z direction, how we will write? Minus nu into stress in x direction divided by E. These formulae we derived in the previous video. You can check it how to derive here. Okay. Next, I want one by one. Strain in x direction, sigma x by E. We know E, Young's modulus. Young's modulus is 2 into 10 raised to 5 MPa. But we don't know stress in x direction. So calculate stress in x direction. Stress in x direction, what is the formula? Load by area. That is load by area. Load in which direction? It is in x direction. Load in x direction. Area is perpendicular to the x load, whatever the load acting on the x direction along the length. So substitute load in x direction is 300. 300, if this is kilonewton is there, convert kilonewton into newton into 10 raised to 3. Divided by area is, area you need to consider perpendicular to 300. Which one is perpendicular? This and this. This is perpendicular. So this is 80 millimeter and this one is thickness is 20. That is 80 by 20. Right? 80 by 20 here. So after simplification we will get 187.5. 187.5 MPa. That is Newton per mm square. Newton per mm square. This is sigma x. Now come one by one here. So strain in x direction is, what is stress in x direction? 187.5 divided by E is Young's modulus. Young's modulus is 2 into 10 raised to 5. 2 into 10 raised to 5. This will be equal to 9.4 into 10 raised to minus 4. 9.4 into 10 raised to minus 4. We don't have any unit here because the formula for strain is change in length divided by original length. So unit, the numerator and denominator both it will cancels. There is no unit for strain here. Okay. Now come to the strain in y direction. Strain in y direction we need to calculate. This is minus, what is the new Poisson's ratio value he is given? 0.3. 0.3 into stress is 187.5. 187.5 divided by E is 2 into 10 raised to 5. 2 into 10 raised to 5. Okay. So simplify this one. We will get 2.8 into 10 raised to minus 4. Similarly calculate strain in z direction. Same the formula, that is minus nu into stress in x direction divided by E. This is same calculation as that of strain in y. So this is same, the strain in y direction, that will be equal to 2.8 into 10 raised to minus 4. 10 raised to minus 4. Okay. So this is how the first bit, strain in x direction is 9.4 into 10 raised to minus 4. Strain in y direction is 2.8 into 10 raised to minus 6. And strain in z direction is 2.8 into 10 raised to minus 4. Now what is the next? We need to calculate deformation. Deformation in x axis, y axis and z axis. It means how much change in length in x direction, y direction, z direction. We will go one by one. So we know the formula, change in length divided by original length equal to strain. This is normal formula. Okay. So if you consider along the x direction, this is strain in x direction, change in length in x direction along the length in the divided by length. This is the length. So substitute here. We want change in length in x direction divided by length is how much? 300 millimeter. 300. This will be equal to strain in x direction is 9.4 into 10 raised to minus 4. 9.4 into 10 raised to minus 4. Okay. So after simplification, the deformation or change in length in x direction equal to 0.28, 0.28 millimeter. So in x direction it is deformed by 0.28 millimeter. By 0.28 millimeter. Now how to calculate the deformation in y direction? Same. Apply the formula, that is change in length divided by original length equal to strain, normal formula. If you consider to the y, the strain, this is in y direction and deformation is in y direction. And how about this L here? L, because we are applying here, it is related to thickness. It is related to thickness. This will comes to the thickness. Okay. So we don't know. We need to calculate strain in y direction divided by thickness is how much? Thickness is 20 millimeter because this is thickness 20 millimeter. 20 equal to what is the strain in y direction here? 2.8 into 10 raised to minus 4. 2.8 into 10 raised to minus 4. Therefore, the deformation in y direction after simplification we will get 0.0056. 0.0056 millimeter. Okay. Now come to the deformation in z direction. Apply the same formula. Change in length divided by original length equal to strain. This is normal formula. If we come to the strain here, it is related to z direction. And change in length divided by change in length in z direction. How about the L here? L is related to this width. Width will come because along the width this will goes to B. Okay. So I want the change in length in z direction divided by width is how much? Width is 80. 80 equal to strain in z direction. We are already calculated 2.8 into 10 raised to minus 4. 2.8 into 10 raised to minus 4. Okay. After simplification, the deformation or change in length in z direction equal to 0.022 millimeter. Okay, this is the first bit. Strain and deformation. We calculated all three strains and deformation in all three directions. Now second bit, change in volume. Change in volume. Okay. How we need to proceed for change in volume? We have the formula. Volumetric strain equal to change in volume divided by original volume. Apply that. Volumetric strain, this is strain in volumetric equal to change in volume divided by original volume. So we need to calculate change in volume here. Okay, change in volume, second bit. So for that we need these two datas. Volume we know already. Volume of the bar 300 into 80 into 20, that we know. And how about the volumetric strain here? First this one. So volumetric strain, this will be equal to just that we can volumetric strain. I can write it as strain in x direction plus strain in y direction plus strain in z direction, because total volume of strain, volumetric strain is strain in x direction plus strain in y direction plus strain in z direction. This you need to substitute. This will be equal to change in volume divided by, what is the original volume? Original volume I will substitute here, 300 multiplied by 80 multiplied by 20. Okay. Now substitute these three values. Already we are calculated here. The before we are calculated the, so change in strain in x direction is 9.4 into 10 raised to minus 4 plus, what is strain in y direction? 2.8 into 10 raised to minus 4, 2.8 into 10 raised to minus 4, again plus same, strain in z direction is 2.8 into 10 raised to minus 4 equal to change in volume divided by 300 into 80 into 20. Now simplify, find out the unknown value. After simplification, the change in volume is, we will get 182.4 millimeter cube. Okay, the total volume change compared to the original volume is 182.4 mm cube. Okay, so this is how we need to calculate the deformations in all the directions, strains, like that. Okay.